Now, we're going to take up one more problem on the cantilever beam. The problem number 9. Find the reactions at the fixed end and draw the SFD and BMD for the cantilever beam. So we have a cantilever beam where one end is fixed, the other end is free. And wherein we have at point B, you have a counterclockwise couple of 5 kilonewton meter at a distance of 2 meters from A, and then 10 kilonewton, which is acting at the point load of 10 kilonewton acting at the point C at 4 meters from A, and clockwise couple at D of 10 kilonewton meter, which is at a distance of 6 meters from A, and at point E, the point load of 5 kilonewton is acting at a distance of 8 meters from A. So find the reactions. To find the reactions at the fixed end, it will going to be the reactions are RAH, RAV, and MA. So first we're going to consider the sum of the horizontal load acting on the beam. Sigma H will be equal to 0. So as there is no horizontal load acting on the beam, therefore RAH will be equal to 0. Now we will going to consider the vertical reaction. Sigma V is equal to 0. The load acting upwards is positive and the load acting downwards is negative. So by sign convention. So plus RAV minus 10 minus 5 will be equal to 0. So RAV will be equal to 15 kilonewton, which is acting upwards. Now consider the moment. So the moment will be taking the moment about the point A. So clockwise couple will going to be positive and counterclockwise is negative. So minus MA minus 5 plus 10 into 4, then plus 10 plus 5 into 4. Sorry, 5 into 8. So that will be equal to 0. So on simplification, MA will be equal to 85 kilonewton meter, which will going to be acting in the counterclockwise direction. Now we will going to consider this the entire beam. So now we are going to take between E and D. So when you are considering between E and D, what will going to be the shear force at the point E? Shear force at the point E will be when you take the section between D and E, if it is acting downwards from the right of the section, will going to be positive. So plus 5 kilonewton by sign convention. So SF at the point D will going to be again, it will going to be plus 5 kilonewton between, because as there is no distance at the point D, as there is no load acting between the point D and E, it remains constant. So therefore, from E to D, it remains constant at 5 kilonewton. Now what will going to be the bending moment at the point E? The bending moment at the point E will be equal to 0, and the bending moment at the point D will be equal to, as the load acting downwards, so the beam will going to try to bend in the downward direction. So that means it will going to hogs. So that means minus 5 into 2 will be equal to minus 10 kilonewton meter. So it will going to be a linear line between E and D, that is from 0 to minus 10 kilonewton meter. It will going to be a linear line. Now we will going to consider the couple at the point D now. So what happens? Once you are considering the couple, so naturally the shear force will not going to have any impact. So the shear force diagram will going to remain the same as the previous one. So that is between 0 to 5. As there is no, for the moment we will not going to consider the shear force will not be considered for the moment. Now we are considering for the bending moment D. So when you are considering BM at the point D now, so what happens? Since it is the clockwise couple, again it's hogs. So minus 5 into 2 minus 10. So it will going to become minus 20 kilonewton meter. So naturally, in the bending moment diagram, it drops from minus 10 kilonewton meter to minus 20 kilonewton meter because due to the clockwise couple. So there will be a sudden drop due to the clockwise couple, which is to minus 20 kilonewton meter here. Now we will consider the next case. When you are considering between, now we will going to consider at the point C now. So we are going to have from E, D and C now. This is the stepwise we are analyzing it. So what will going to be the shear force at the point C now? So between D and C, SF remains constant. So that will be equal to minus 5 kilonewton, sorry, plus 5 kilonewton. At the point C, since you have 10 kilonewton point load which is acting, so plus 5 plus 10, it will going to become plus 15 kilonewton. So at the point between D and C, as there is no other load, SF remains constant at 5 kilonewton. At the point D, at the point C, 10 kilonewton is acting downward, so plus 10, it becomes plus 15. It will going to rises to plus 15 kilonewton because due to the point load at the point C, which is 10 kilonewton. Now, what will going to be the bending moment? The bending moment will going to be at the point C, that is minus 5 into 4 minus 10, which will be minus 30 kilonewton meter. So that is from minus 20 kilonewton meter, it will drops down to minus 30 kilonewton meter. It's going to be a linear line between minus 20 kilonewton meter to minus 30 kilonewton meter. So now, when we are considering for the point B now, when you are considering at the point B without couple, so see what happens. So between C and B, as there is no other load acting between C and B, the SF remains constant at plus 15 kilonewton. So SF at the point B will be equal to plus 15 kilonewton. So as we see here, between B and C, it remains constant at plus 15 kilonewton. Now, when you're considering at the BM at the point B, so that will be equal to minus 5 into 6 minus 10 into 2. On simplification, you will going to get it as minus 60 kilonewton meter. So at the point B, the bending moment diagram further drops down from 30 kilonewton meter to 60 kilonewton meter and by means of a linear line between 30 to 60. Now, when you are considering for the last one, that is at the point couple, when you are considering the couple there, so what happens? So since you have as we are considering the couple, so there is no change in the shear force diagram because the couple will not going to have any effect on the shear force. So therefore, the shear force diagram between C and B, it remains constant at 15 kilonewton. But when you're considering the couple, what will going to be the bending moment at the point B? The bending moment at the point B will be equal to minus 60, that is minus 5 into 6 minus 10, minus 5 into 6 minus 10 into 2 plus 5. So that means that is minus 30 minus 10 40 minus 20 minus 60 plus 5, it becomes minus 55 kilonewton meter. So because due to the counterclockwise couple, the beam will going to sag at this particular point by 5 kilonewton meter. So it becomes positive. So it will be minus 555 kilonewton meter. So therefore, the bending moment, there will be a sudden rise due to the counterclockwise couple. So that you will going to have the point from 60 kilonewton meter, it rises to 55 kilonewton meter. Then in the finally, when you are considering for the entire beam, we are considering between B to A now. So when you are considering for the entire beam, there is no load between B and A, the SF remains constant at plus 15 kilonewton. So SF at A will be equal to plus 15 kilonewton. Between B and A, SF, as there is no other load, SF remains constant at plus 15 kilonewton. So this is how you will going to get the shear force diagram, which is the complete SFD. Now we will going to consider what will going to be the bending moment at the point A. The bending moment at the point A will be equal to minus 5 into 8 minus 10 into 4 plus 5, which will be equal to minus 85 kilonewton meter. So further from minus 55 kilonewton meter, it further drops down to minus 85 kilonewton meter. So this is how you will be able to get the final bending moment diagram. So this will going to be the final solution for this particular problem. Thank you.